Today we discuss on physics grade 11 chapter 4 dynamics. Based on this course outline 4.1, 4.2, 4.3, 4.4, 4.5 and 4.6. When we start from the beginning, we discuss on unit 4 dynamics. From this we start from the definitions of this dynamic. Dynamic is the branch of physics that studies the cause of motion. This cause of motion is a force, and the change in the motions they produces, it always object move the way they do. From this one, we discuss on the cause of forces. This cause of force can change the shape of a given object, can change the directions of the given motion, can change the speed of, etc. This is about the cause of forces. So this under this unit 4 physics grade 11 chapter 4 we discuss on the dynamics, and under this we discuss on what the concept of Newton's second law of motion, Newton's laws of motion. There are as we have learned in the class, there are three types of Newton's laws of motion: Newton's first law of motion, Newton's third law of motion, Newton one first law, second law, and the third law. Under this, we start from the beginning by means of what defining the meaning of forces. What is a force? A force is a push or pull an object due to interaction with the others. This pulling or pushing the object with interaction with other can be at a distance, or can be what by means of physical contact. From this one, force is a vector quantity. And we have to know the magnitude of this physical measurable. Also, we have to know the directions of this application when we talk about this physical measurable. Means interaction means at a distance, and physical contact means the physical contact is when two bodies physically contact with each other, when exert with each other. And force at a distance means such as what magnetic field, electric field, and etc. So the SI unit of a force is Newton, which is a capital and N, capital N. When 1 Newton force is exerted, when 1 kilogram object is multiplied with what 1 meter per second is 1 meter per second. And from this we discuss on what the first about the starting from what Newton first law of motion. When we come to the Newton first law of motion, what is the Newton first law, and what is the idea of Newton first law? Before that, when we go to the common forces, there are common forces such as gravitational force, normal force, tension force, friction force, applied force, and spring forces. Here, what is the gravitational force, what is normal force, tension force, friction force, applied, and spring forces? We discuss the next session, starting from the Newton first law of motion. When you go to Newton first law of motion, Newton first law states that if an object at rest stays at rest, and object in motion stays in motion with a constant velocity with what the same speed in the same direction, unless acted upon by the external forces. Meaning that in a given object is to start or change its direction if there is what the external force is exerted, until that the object is what move with what the same direction with what the same speed. Under this Newton first law of motion or law of inertia, when we come to starting from the meaning of what inertia means, what is inertia? Inertia is the tendency of an object to resist change in motion. This change in motion is depending on what this mass is. For more mass, there is more inertia. For light masses, there is light inertia. directly related with what? The mass, the tendencies of what? An object to resist motion, or change in motions. From this one, if the net force on a given object is equals to 0, if the net of force exerted on a given object is equals to 0, we say that that object is in equilibrium, or this object is, the velocity of this object is a constant, or could be 0. Here about what? The directions, the motion, and also the speed of the object. When we come to the second Newton's second law of motion, from this one, when we come to the Newton's second law of motion, law of acceleration, the motions of a given object, the acceleration of a given object, directly related with what? The applied forces, related with applied force. From this one, let we starting from defining the Newton first, the second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its masses. From the given this equation is what written as what? This assume we have net forces, and net forces is what? Accelerate the objects in the directions of the applied forces. For the mass is constant. When the forces increase, also there is increasing the acceleration. When the forces decrease, also there is decreasing the acceleration. If the mass of this object is what? Unchanged or remain constant, there is directly proportional the force in this acceleration. When we come to the relation between masses in this acceleration, means that if the force is what? Constant, there is directly inversely proportionality between the acceleration and the masses. For light mass, there is what? High acceleration. For maximum forces, there is what? Small or minimum acceleration. Inversely proportionality between mass and acceleration. From this one, directions of acceleration is equal with directions of what? The net forces. When the force is exerted in a given direction, let's say in east direction, the acceleration is also in east direction. When the force is exerted in west direction, the acceleration also in that way. From this one, if a net force on a given object is equals to 0, then acceleration of the object is equals to 0, means a constant with what? First Newton first law of motion. Newton's first law of motion. When we go to the Newton's second law of motion, so Newton's third law of motion states that from this Newton first law, Newton's third law states that for objects or for motions of a given object, for every actions force, there is an equal and opposite reaction forces. When when a given object is exerted on other object, that object is also the receivers of the forces also exerting equal forces on the first one. From this one, for action in the reaction act on different objects. From this one, when we come to a good example, foot pushes backward on the ground. This is taken as what? Action forces. Ground pushes forward on foot. This is taken as what? Reaction forces. Reaction force. This is about what? Newton's third law. When we come to Newton, the frictional forces. A frictional force means when you define the meaning of this, friction is a force that opposes relative motion or attempt to motion between two surfaces in contact. From this one, we can determine or define the frictional forces, and it is what type is. So static friction, friction that opposes starting motion. A kinetic friction. A kinetic friction is frictional forces that oppose sliding the motion, and rolling friction is frictional forces that opposes the rolling motion, usually smaller than the kinetic. From this, there is also a fluid friction opposes motions through the fluid. This fluid can be air or water, depending on it is what speed in the shape. And the other we have to know about this frictional force is directly there is what? Coefficient of static friction. This coefficient of static friction can divide it as what? Coefficient of static friction or coefficient of kinetic friction. Coefficient of kinetic friction is what? When you compare with coefficient of static friction is more greater than coefficient of kinetic friction. The point we have to know here is what? When we come to the point here, static friction has a maximum value up to the values it matches the applied force. And once motion starts, kinetic friction is usually constant. Friction does not depend on the surface area. In simple, it is what? Modulus. The other we have to know here is what? The coefficient, the equilibrium. What is equilibrium? Equilibrium condition means from this one. Equilibrium. When we say equilibrium, 4.3 equilibrium, transitional equilibrium. An object is in transitional equilibrium when the net force acting on it is zero. From this, to say given object is in equilibrium when the net force on that object is equal to zero, according to the given, as I try to showing you in the screen. On the screen here, the net force on a given object is totally equal to zero. All the summation of forces. This all summation of force can be when we come to in the axis. Maybe on the force, all the force on x-axis is equals to zero. All the force, the summation of force on y-axis is equals to zero. All the summation of force on z-axis is also zero. When we're talking about in the three-dimensional forces, the result of this one, object is either at rest or moving with a constant velocity, no acceleration. When we talk about this one, the good examples of this one is, let we talk about a given book which is resting on a table. From this one, when the book is resting on a table, there is what? Force which downward and the force which upward. The force which is exerted from the table on the book upward, the force which is exerted from the book down on table is what? Downward. So downward is equals to weight, which is the product of mass of the object times gravitational field strength. The upward is the normal forces. When we come to the ideas of these normal forces, there is what? If the force is what? Exerted, once wait me. If the force is what? Directly upward, just this a pointer is what? The force which is exerted on the upwards, assuming there is what? Given. Okay. This is what? Upward. This is what? Upward direction. And also, if there is what? Downward direction. A downward direction. This is what? The force from what? The table. And also, there is a given forces which exerted on downward or upwards from the given this one. The Fn means normal force which is upward, and mg which is equals to mg. When the normal force is equals to weight which is equals to 0, Fnet is equals to the weight of the product of mass of the object in gravitational field strength. Under this, we discuss on the work energy in theorem. When we come to the work energy in theorem, here there is what? Work energy in power. What is work? Let me define meaning the work. Work is done when the force causes displacement in the directions of the forces. The formula for what? Formula constant forces starting line. Assume you have what? A given force which is exerted on object, and that object is moved in the directions of what? The applied forces. And then the equation is given by W is equals to F times D times cos theta, when F is the applied forces and D is the displacement of the object, and cos theta or angle is the theta is the angle between directions of the force applied forces and directions of the displacement. From the given this one, when we come to theta means the angle between force and displacement. From this one, there is effect of what? Sine effects of thetas on of what work is from the given this one, we have three important points. When angle theta is equals to 0 degree, positive force is increased, speed is equals to, speed is increased from this one, cos of 0 degree is equals to 1. When we insert this 1 into the product of the above, means force F times D times 1, we will get what? The product of, this is what? Simply the product of applied force times what? Displacement. When the angle between the applied forces, directions of the applied forces and displacement is 90 degree, means due to the values of cos of 90 degrees equal to 0, when we insert the given value into the above equation, means F times displacement times 0, we will get what? The work done, or the work done on this one is what? Equals to 0. It depends on the angle theta. The third probability, when the angle between the directions of the applied force and displacement is equals to 180 degree, there is a negative force decreasing speed, meaning the cos of 180 is equals to negative 1. Inserting into this above equation, W is equals to F times displacement times minus, which is what? Negative of this one, which is equals to negative, means it is what? Speed decrease by given value. The next one is about the frictional forces, kinetic. Here is what? Kinetic friction, kinetic energy. Energy of what? Motion. When we come to kinetic energies directly, it is what? Energy due to this motion. Object in motion has what? These types of energy. Which is equals to, kinetic energy is equals to half mv square, when m is the mass of the object, v is what? Speed of the object. Under this, we discuss on what? Work energy theorem. According to the work energy theorem, work is equals to the change in kinetic energy. Means that delta of kinetic energy is equals to final kinetic energy minus initial kinetic energy. Will get what? Given the net work is equal change in the kinetic energies. Under this, we discuss on what? The potential energy. What is the potential energy? Means energy due to what? Gravitational. This is defined as what? Energy due to this what? Position. Means gravitational potential energy is equals to the product of mass of the object times gravitational field strength times height of the object. When we define the given this, h is what? Height above the reference point is, g is gravitational due to the gravity, m is mass of the object. And the next one we discuss on what? On is about power. When we come to power, is definitions of power. Power is the rate of doing works, and power is equals to work done over time. When work done is the product of F times SC, and time is what? T. The SI unit of what is represented by capital W. From this one, W is equals to when 1 joule is what? Transferred in 1 second. We say that there is what? 1 power. The other unit of power is what? Horsepower. When 1 horsepower is equals to 746 watts. And the 4.5 is conservations of mechanical energy. What is the mechanical energy that we discuss with each other? Conservation of mechanical energy means mechanical energy is the sum of potential energy in the kinetic energy, which is represented the sum of all possibility in kinetic energy and all possibility in potential energy. Under this, the law of conservation of mechanical energy states that if the only conservative force such as gravity, spring force do work, then the total mechanical energies remain or unchanged. Let's go to the next one about the impulse. What is impulse? Impulse in the linear momentum. Linear momentum is what? The measure of what? The quantity of motion. Which is momentum is equals to mass times velocity, and it is vector quantity. Vector quantity is the same direction as velocity, and the SI unit of this momentum is what? Kilogram times what? Meter per second. Newton's second laws also there is directly relation with what? F net is equals to change of momentum over time. Force is equals to rate of change of momentum, and impulse is also equal to change in the momentum. From this one, impulse is equals to the average force times what delta of what time, which is equals to change in momentum. In general, the other here is what impulse is a vector quantity, means the same direction as the net forces. Large force over a short period is equal the same impulse as a small force over the long time. These laws of conservation of mechanical energy momentum, laws of conservation of linear momentum states that if the net external force on a system is zero, the total linear momentum of the system is what? Constant. From this one, the total initial momentum is equal with what? The total final momentum. In general, today we're discussing on physics grade 11, chapter 4 about physics grade 11 about the dynamics. We're discussing the here is what unit 4 dynamics. What is the dynamics? Means it is what a branch of physics that studies the cause of motion. This cause of motion means when a given force is exerted on a given object, can change the shape, can change the direction, and etc. Under this also discuss on what 4.1 the concept of forces in Newton's second law. What is a force? Force means pushing or pulling something is in Newton. When you come to Newton's law of motion, there are 3 Newton's law of motion: Newton's first law, Newton's second law, Newton's third law. And also discuss on what the types of what work, energy, and momentum. For example, there is what frictional force. We discuss on frictional forces. On it is depend. There are what frictional forces, and also we discuss on the types of what first conditions of equilibrium. Is what is the first conditions of equilibrium? If is the total force exerted on a given system is equals to 0, we can say that it is what Newton first condition of equilibrium. They also discuss on the work, energy, power. When what is work? The force exerted on a given something can what moves in a given direction is directly interpret the amount energy transfer. The same is to energy and power. In general, if you have an equation, also discuss on what the theta sign of fork effect is. Also discusses. Walumaa gala irraa akka wal wajjin barannee fiiziksii kutaa 11 boqonnaa arfaffaa daayinaamiksii kan jedhu. Daayinaamiksii kan jennu taatee humnaati. Humni maal gochuu danda'a kan jedhu jedhatti humni saffisa wantaa waan deemaa jiru jijjiiruu isaa, boca wantootaa jijjiiruu isaa ilaalle. Akkasumas immoo taatee humnaa kana jedhatti konseptii humna jechuun maal jechuu akka ta'e seerota sochii Niwutenii sadaffaa, seerota sochii tokkoffaa, lammaffaa, sadaffaa kan jedhu ilaallee turre. Akkumaan achumaanis immoo humna rigataa kan jedhu ilaallee humni rigataa maal ta'e akka ta'e tokko tokkoon ilaallee turre. Achumaanis kondiishinii equilibriumii jira kan jedhu tokko siistemii tokko yoo maal ta'edha kan jedhuudhaa fi yoo humni waliigalaa irratti dalagaa jiru 0 ta'edhanne kan biraa dalagaa hannisaa fi aangoo kan jedhu ilaallee turre. Isaan kana irratti gaafilee yookaan yaada yoo qabaattan na barreessaa. In general, if you have any question, suggestion concerning this my lesson, please write me your suggestion in my inbox. በአጠቃላይ በዚህ ዛሬ የተማርነው 11ኛ ክፍል ፊዚክስ ቻፕተር 4 ነው። ዳይናሚክስ ማለት ፎርስ እንዴት ሁኔታውን ሊቀይር ይችላል። ለምሳሌ ነገሮችን ሼፑን እንዴት እንደሚቀይር under this we discuss on the types of forces. ፎርስ ምን እንደሆነ ተምረናል። የኒውተን ሎ የምንላቸው አንደኛ፣ ሁለተኛ፣ ሶስተኛ ምን እንደሆነ ተምረናል። በዚህ ቀጥሎ ደግሞ የተማርነው ፍሪክሽናል ፎርስ ምን እንደሆነ የተማርነው። ፍሪክሽናል ፎርስ ማለት አንድ ነገር ወደፊት ለመሄድ ሞከረው ቁጥር ሬዚስት የሚያደርጋቸው ፎርሶች አሉ። እነዚህ ፍሪክሽናል ፎርስ ብለን የምንጠራቸው ተምረናል። ቀጥሎ ኮንዲሽናል ኢኩሊብሪየም የምንለው ምንድነው? ስራ፣ ወርክ፣ ኢነርጂ እንደ ፓወር እንዲሁም ተምረናል። በአጠቃላይ ለዚህኛው ለ11ኛ ክፍል ተማሪ ይሄ ቪዲዮ በጣም ይጠቅማችሁ ብዬ አስባለሁ። እንዲሁም 12ኛ ክፍል ለምትማሩ ተማሪዎች በአጠቃላይ ፈተና ላይ ይሄ ጥያቄ ይሄ ፖርሽን ሊጠቅማችሁ ስለሚችሉ ተከታተሉኝ ብዬ አግዛችኋለሁ። አመሰግናለሁ። In general, this is what the physics grade 11 chapter 4. If you have any question, suggestion.